Chapter 7, the quantitative composition of compounds. This chapter is going to be all about the mole, and that makes this chapter either the easiest chapter or the hardest chapter for students. The mole is a word, and it is a word that stands for a number. Just like a dozen is a word. If I have a dozen donuts, you know that I have 12 donuts. If I have 2 dozen donuts, I have 24 donuts. A dozen is a word which stands for a number. The mole is no different. It's just a much bigger number. So a mole is 6.022 times 10 to the 23rd of something, whereas a dozen was 12 of something. If you can rationalize a mole just being a word which stands for a number of things, this will be a relatively straightforward chapter. Otherwise, it gets really difficult really quickly. So again, a dozen is 12 of something. A half dozen is 6 of something. A ream is 500 of something. A gross is a dozen dozens, 144 of something. And again, these are all words which stand for a number. And the mole is no different. A mole just means you have 6.022 times 10 to the 23rd of something, just like if you have a dozen of something, you have 12 of something. Again, the mole has the greatest abbreviation in all of science, where MOLE is abbreviated to MOL, because writing that last E is exhausting. So with the greatest abbreviation, we have the mole, and chemists always write it MOL. They take the abbreviation seriously. So a mole of atoms is 6.022 times 10 to the 23rd atoms. A mole of molecules is 6.022 times 10 to the 23rd molecules. A mole of electrons, 6.022 times 10 to the 23rd electrons. The reason you don't see this in everyday life is this is a gigantic number. It is huge, super gigantic. You never have this many of normal-sized things. There are not a mole of grains of sand in the universe. That's too big of a number. And so the only things that you can have in this large number are atoms, molecules, ions, and then subatomic particles. And so this is a word that is typically used just with science. But at its core, it's no different than the dozen. It is a word which stands for a number of something. It doesn't matter what those somethings are. If you have a mole of tortoises, you have 6.022 times 10 to the 23rd tortoises. It's just that there aren't that many tortoises on Earth. In fact, if you add up the entire history of Earth, there haven't been that many tortoises. So this word is typically just used with subatomic particles, atoms, ions, and molecules, because those are the only things you get in this number on a regular basis. The mole is the number of atoms of carbon-12 and exactly 12 grams of carbon-12. So carbon-12 here is our standard for the mole. And again, 1 mole of any element contains 6.022 times 10 to the 23rd atoms. However, the overall mass can be very different because different atoms have different masses. So the molar mass is the atomic mass of an element. If you take your trusty periodic table, we can now look at the atomic masses in 2 different ways. We can say hydrogen is 1.008 atomic mass units per atom, or you could say it's 1.008 grams per mole. And this is why the mole is so useful, because the mole will allow us to convert from atoms or molecules into grams. What we need to know is the number of molecules when we're figuring out ratios in chemical reactions. But we don't have a tool that can measure that. What we have in our lab is a mass balance, which tells us grams of stuff. And so chemists on a regular basis have to convert between the mass of something and the number of atoms of something. And we'll get back to determining the molar mass of compounds here. So, how many moles of lead does 15 grams of lead represent? Well, I find my trusty periodic table. This is always found on the periodic table. And I find that the atomic weight of lead is 207.2 grams. And so that's 207.2 grams per mole. And that's my conversion factor. 15 grams of lead times 1 mole of lead divided by 207.2. We're converting into moles, and that's why moles goes on top. If we were converting into grams, then grams would be on top. Again, whenever you use a conversion factor, the unit that you're converting into goes on top, and the old unit goes on bottom. And we get 7.24 times 10 to the minus 2 moles of lead. How many moles of mercury does 23 grams of mercury represent? We take out our trusty periodic table and we find that mercury's atomic mass is 200.6 grams per mole. And that's our conversion factor. 1 mole of mercury is equivalent to 200.6 grams of mercury. And we get 0.115 moles of mercury, or 1.15 times 10 to the minus 1 moles of mercury. So again, if you're converting between grams and moles, you must use the periodic table. That's the only place you'll find the conversion factor between grams and moles. If you're converting between moles and molecules, or moles and atoms, you just have to remember 1 mole of something is 6.022 times 10 to the 23rd of something. How many gold atoms are contained in 16 grams of gold? Well, I find gold on my trusty periodic table, and it's 197 grams per mole. So I have 16 grams of gold times 1 mole of gold over 197.0 grams. And now they wanted atoms, so I have to convert moles into atoms. There are 6.022 times 10 to the 23rd atoms of gold in 1 mole of gold, giving me my answer. And again, if you get confused with that last conversion, just pretend it's a dozen. If you had 4 dozen donuts, how many donuts would you have? 48. Because 4 dozen donuts times 12 donuts divided by 1 dozen donuts. And again, you use the mole the exact same way. So if you're not sure how to operate with the mole, just for a second pretend it's a dozen, and wherever you would have written dozen, replace that with mole, and wherever you would have written 12, replace that with 6.022 times 10 to the 23rd, and you'll be on the right track. How many titanium atoms are contained in 7.8 grams of titanium? Titanium is a cool metal because it has the same strength as steel but half the weight, and so it's useful in weight reduction. The lighter alloys like magnesium and aluminum are a lot lighter than steel, but they're a lot weaker too. So what's unique and useful about titanium is that it maintains the strength of steel and it cuts a lot of weight. So we must find titanium on our trusty periodic table. And the molar mass of titanium is 47.87 grams. So we convert 7.8 grams of titanium times 1 mole of titanium over its molar mass, 47.87 grams titanium. And now they wanted atoms, so I have to convert moles into atoms. Again, if that was a dozen, it would be 12 over 1 dozen. But it's a mole, so it's 6.022 times 10 to the 23rd over 1 mole. So we convert a mole into atoms by remembering that 1 mole of anything is 6.022 times 10 to the 23rd of those things. What is the mass of 2.13 times 10 to the 18th atoms of lithium? Lithium is a very light metal, only 6.941 grams per lithium. At the end of the day, the difference in atomic masses is all about the weight of each atom. And so lithium has a very small nucleus, whereas lead has a gigantic nucleus. So lithium is atomic number 3, whereas lead, that was atomic number 82. Much, much, much bigger nucleus, way more protons and neutrons, and much more mass per atom. So to convert atoms to grams, we go the opposite way that we've been going before. The last couple of problems have been grams to moles to atoms. Now we convert atoms to moles by remembering that 1 mole of something is 6.022 times 10 to the 23rd of those somethings. And then we convert a mole into grams for lithium. Whenever you convert between grams and moles, you need your trusty periodic table. And 1 mole of something is 6.941 grams, because that's what it says in the periodic table. And that only applies for lithium. So you have to find the atom on the periodic table, find the atomic mass, and read it as grams per mole, and that's your conversion factor. And again, now we're converting into grams. So grams goes on top, And moles is on bottom. And that gives us 2.46 times 10 to the minus 5th grams of lithium. Very small amount. What is the mass of 1.28 times 10 to the 8th atoms of neon? Well, you have atoms, we convert to moles, and then to grams. We convert atoms to moles, remembering that 1 mole of something, of anything, is 6.022 times 10 to the 23rd of those somethings. And then we have to actually use our periodic table to go from moles to grams. We look up neon, it's 20.18 grams per mole, and then we convert moles to grams to get 4.29 times 10 to the minus 15th grams. What is the mass of 1.05 moles of silver? Well, we have 1.05 moles of silver, and we look at our periodic table, and we see that it has a molar mass of 107.9 grams per mole. We multiply it, 113 grams of silver.